Hello everyone, this is Pre-Calc Lesson 61, ignore my little typo there, single variable analysis, the normal distribution, and box and whisker plots. So single variable analysis considers the variation of a single measurement, usually represented by x. And we have these new terms. We've talked about mean before. Mean is an average. It's represented by this symbol here, mu. We also sometimes see it as x bar. So either one of these symbols can be used. A range from the lowest point to the highest point. Variance I'll talk about in a minute, and standard deviation we represent by sigma. Okay, so how do we find standard deviation? We first find the mean, mu, okay? Then you find the deviation for each data value. What that is the data value minus the mean. The deviation is how much do they differ by. Then you square the deviations, add the squares of the deviations, divide by the number of data points. This is the variance. The variance is sort of the varies between all points. It's kind of a type of average. And then you take the square root of the variance and it gives you standard deviation. So let's look at an example. Okay, we have the measured distances are 12, 7, 15, and 10. We want to find the mean and standard deviation. Finding the mean is the same way as you've always done. You add up all the values and divide by the total. So our mean, mu, 12 plus 7 plus 15 plus 10 over 4 gives us 11. Now we're going to find the distance between each of these points, 12, 7, 15, and 10, and 11. We square those distances and divide it by 4. So 12 minus 11 squared, 11 minus 7 squared. Now it doesn't matter if you would do 7 minus 11 because 4 squared and negative 4 squared are both a 16. So it doesn't matter which way you go. 15 minus 11 squared and 11 minus 10 squared divided by the values 4. So these are all the values divided by 4. This is our variance. Our variance is 8.5. Now to find our sigma, our standard deviation, we take the square root of 8.5. So sigma is 2.92. Okay, you'll see a lot of examples like this in your homework to come. Now let's talk about normal distribution. Okay, you've probably heard about normal distribution before. Wasn't really sure of it. Maybe you were. And it's a theoretical frequency distribution. We sometimes call it Gaussian distribution, and it's approximated by data collected experimentally. So it looks like a bell curve. The mean, mu, is at our center, and the mean, median, and mode, or average, middle, and most, are equal. Now, this could be the normal distribution of height of 14-year-olds or weight of adults or something like that. That would be normally distributed. Okay, now we can have a small standard deviation where all of the values are closer to the mean, or a large standard deviation, the values are more spread out. When we get to, I believe it's lesson 70, we're going to talk a lot more about normal distribution and how we find it using a normal distribution table. But for now, we'll just do a simple version of it. Okay, now what you need to know, we have these three important concepts about normal distribution. 68% of the data is within one standard deviation. So if our mean is 100, a standard deviation up and down would be 1 sigma away, or 1 standard deviation away. So if sigma is 3 from 100, 68% of the data would be between 97 and 103. 95% of the data is within 2 standard deviations, so 2 times our standard deviation up and down, so 95% of the data lies between 94 and 106. 99% of the data lies within 3 standard deviations, so between 91 and 109, or 3 times sigma, which is 9. We do 100 minus 9 and 100 plus 9. You need to know the 68, 95, and 99 because you'll be given questions like this. The mean of a distribution that is approximately normal is 100, so mu is 100. And the standard deviation is 5. Tell how the data are distributed. So what does that mean? We know that 68% is within 1 standard deviation. So 68% lies between 100 minus 5, so 95, and 100 plus 5, 105. We have 95% of the data lies between 2 standard deviations, so 100 minus 10 gives me 90 and 110. and 99% of our data lies between 3 standard deviations, so 85 and 115. Okay, this is the information that it's asking for. Okay, now you could also get examples like this. The mean of a distribution that is approximately normal is 100, so we're looking, that's mu at the same problem. Okay, and the standard deviation is 5. What percent of the data lies between 95 and 100? Now we know that 68% of the data is between 95 and 105. We're only going to 95 and 100. It's half of the 68. So we do 68 divided by 2, okay, which would give me 34% of the data lies between 95 and 100. Now, these are different types of normal distributions you'll see. You can see negatively skewed, it's skewed to the right. Positively skewed is skewed to the left. Just like when we have horizontal translations, if we go to the right, we have x minus some value. To the left, we have x plus some value. And bimodal distribution, we have 2 different means. We're not really going to get into that a whole lot. It's just an interesting fact for you. Bimodal distribution would come, for example, from grades on a test. If people get A's, B's, and C's, kind of what those averages look like. All right, now let's talk about stem and leaf plots. You've probably done this before, okay? Stem and leaf plots, the stem represents the highest place value, such as the tens value, and the leaf is the lowest place value, the unit value. So if we were given this data, make a stem and leaf plot, we first need to write our data, okay, in order. Now, you don't have to do this, okay? I'm going to do it without. Okay. Now, as I said before, our tens place, so we will start at the highest. We have 9, then we see 8, and we have 7, and we have 6. We don't have anything below 60. Okay, so that should tell us that 6 is our lowest. Okay, so I'm going to start at the bottom just because I think it's a little bit easier. We start here at 0. Okay, and then I go up to the next highest value, 8. So I'll have 0, 8. Next highest value is 9. You want to go from lowest to highest. Okay, then I'm going to look at my 7s. Okay, I have 78 and 71, so the 1 comes before the 8. Look at our 80s. I have 80, so that's the 0. Then I have 83 and 87, so 3, 7. Then I go to 90, I have a 0, and I have a 2, and I have a 5, and a 6. That's my stem and leaf plot. Now, stem and leaf plots really show you all your data laid out linearly. If we were to find the range of this, you do your highest value, 96, minus your lowest value, 60. Now, if we were to find the median, we'd need to put these numbers in order. And you can cross out from left to right, get all the way to the middle, and that is your median. Okay. Let's talk about box and whisker plots. They have a lot more that go into it. Box and whisker plots, the values that you will need, you'll need your minimum, your first quartile, your median, which is your second quartile, your third quartile, and your max. Now, all of those show different values, okay? Now, I'm going to show you how to do this in your calculator, okay? Now, one more couple of things before we actually get to that. You can have your inner quartile range. That's something you might be asked for. And that's your third quartile minus your first quartile. And they might ask you for outliers. Okay, outliers is data greater than the median plus 1.5 the inner quartile range. Okay, or data less than the median minus 1.5 the inner quartile range. Okay, we'll get to that later. You won't be asked for outliers, I don't believe. So I'm not going to really get into that. Okay, but I do want to look at this example. The measurements are 16, 22, 28, 33, 35, 40, 50, and 120. We want to find the mean and standard deviation, the min, the quartile 1, median, quartile 3, and max. So, and make a box and whisker plot. How do you do that? So, in my calculator, I go again to stat, just like we did when we were doing linear regression, and I press enter. Now I need to clear my first list. Okay, the first list is what matters. Now I need to enter my points, so I have 16, 22, 28, 33, 35, 40, 50, 120. It doesn't matter what's in the second list. We're not going to be using it. We're only using the first list now. We go back to stat and over to calc. Okay, and the first option is one variable statistics. That's what we're doing. So you press enter again, and it gives you all of this information. So I'll write it down. It says x bar is 43, ex is 344. It's not really an e, but it's the easiest way to describe it. And we have 32.83, sigma x is 30.71, n is 8, mine has an arrow to go down. Then it says min x is 16, q1 is 25, median is 34, q3 is 45, and max x is 120. Okay, so now I'm going to show you how to graph this by hand. Okay. We draw a line. Okay, this is your min. Now it tells me my min x is 16 and my max is 120. Okay, and then it tells me my median is 34, quartile 1 is 25. So this next line here becomes Q1, which is 25. Okay, then I have a line here which is 34. It's my median. And another line here, which is 45, quartile 3, and I draw a box whisker plot, and a line down here. Okay, I have drawn my box and whisker plot. I have labeled, it asks me to find my min, max, min, I can even label it here. Min, max, quartile 1, median, quartile 3. Now, if you label it here on your box and whisker plot, that's fine. You don't have to write out these values here. But at some point, you cannot just label it 16 and assume I know what you're talking about. You have to show me you know that that's your minimum. Okay? It also asks me to find my mean. I told you guys that mean was x bar. Okay? That is my mean. Okay? Then it asks me to find my standard deviation. My standard deviation is 30.7. Okay, that's what it tells me. That's what the sigma is. This information you don't really need. This just tells me the number of points. Okay, if you were to do this problem, and by if I mean when you do this problem, you do not have to write out all of this. You can just write out what it asks for and draw your box and whisker plot. Okay. Again, just like I will with the linear regression, I told you guys I'd give you a worksheet that has, or a packet that has all of the cheat sheet things of how to do it on the different calculators. I'll be giving that to you guys already, or you already have it. So that will help you to be able to know all of this for your specific calculator. And as always, if your specific calculator isn't in there or you have a question, you can always ask me. If I'm not available, you can Google it. You can just type into Google box and whisker plot and the type of your calculator, and it will come up with how to do it. Okay, so once again, I'm giving you permission to go play on your calculator to be able to start to practice this. And that is all for single variable analysis as for now.